And on to our fifth and final speaker of the first part of today's session is Jerwin P Mercado from Moru and the Faculty of Tropical Medicine, Mahidol University, Bangkok, Thailand.
You may know it as Bensoy, Champak, Hat, or Tigdas. And you see it marked on the face of this child. Wherever it hits, it's the same old story. Outbreaks, loss, disruption. Despite decades of vaccines, it still kills 100,000 people every year, mostly kids under 5. This is the story of measles. I'm VJ, and I'm building a model to track how measles spreads. Think of it as a journey between two places: the green zone of protection and the yellow zone of risk. And you can think the ways between these two as the tunnel of infection and the bridge of vaccination. When we are born, we start in the green zone of protection, thanks to the protection we get from our mothers. But around 6 months, this shield fades and we move to the risk of protection, waiting to be protected again or be infected. Once we are exposed, we get red and we enter to the tunnel of infection. After about 2 weeks, we recover and return to the zone of protection. But that path is risky. 1 in 100 people who get infected die. What's worse is that one infected person can infect as many as 18 others, causing the outbreak to spread just like a wildfire. On the other side, you have the bridge of vaccination. And to enter that bridge, you need 2 doses of the measles vaccine. But here's the catch. Even the protection that you get from vaccines fades over time. I know that you are teenagers, but by your 20s, infection is already possible, although the infection can still be mild. In my digital laboratory, I use these zones, tunnel, and bridge to simulate how measles spreads. I decide how many people should be in each zone. I decide how many people or how fast people move through the tunnel and across the bridge. And then I spark an infection. If I spark an infection, I now watch as an outbreak unfolds before my very eyes. Using the same setup, I introduce some small changes. Maybe I broaden the bridge, I narrow the tunnel, or maybe I add another dose of the vaccine to make sure that those with fading protection remain protected. Every change allows us to see which strategies work best and which will produce the smallest outbreak. With infectious disease modeling, we can rewrite the story of measles, the story of this child, and the story of million others. With simple strategies like this, we can now say, it's time to stay green with the power of the measles vaccine. It's time to shrink the yellow. It's time to make transmission slow. And it's time to stop the red and shrink the spread. Thank you.